morning. On the bench today, a NerdQaxe++. This happens to be a Parasite edition. Cool red. Customer's complaint. Fan twitching. Says, fan not working, added a new fuse, only made fan twitch 99%. It's a MOSFET. All right, let's take a look. All right. Quick visual inspection. I'm looking for anything obvious. Cracks, burned components, things to that nature. Pull the display off. Take a look at the controller. I see he's got a 10 amp fuse. These things ship stock with 8 amp fuses. So pretty likelihood that he's overclocking it, or he went to a 10 thinking it would solve his problem. I see original BOM parts on here. These coils are the original BOM called out parts. We'll take a quick look at these ASIC chips. Make sure we don't have any cracks. That looks good. That looks good. Those look good. Let's just get another look quick clean here. Yep, that all looks good. Temperature chip. All right, we'll flip it over to the back side. Everything looks pretty good. All right, so nothing visible. Pretty typical on these pluses, or really any of these nerd devices that have parallel power supply. And by parallel power, what that means is we have 3 CSDs or VREGs, as you commonly hear them, that all are controlled by the controller, pulsing, taking 12 volts from one side, outputting the desired voltage out to the ASIC chain. Okay. So first thing I'm going to do, I'm going to take my meter here. I'm going to put the negative on the shroud, and I'm going to put the positive on the bottom side of this fuse, and we're going to check the resistance. So I'm getting 0.3 ohms. Now this tells me immediately that down this chain somewhere I've got a short to ground. The ASICs on all of these devices will always act like a short. So when I read this, this is telling me I either have a component here on the front side or down this line that is shorted to ground, or I have an ASIC, or I'm reading through the ASICs. In this case, I think I'm reading through the ASICs. We're going to find out in a minute. Okay, we shouldn't. If we're reading through the ASICs, we should not. That tells me that we likely have a problem here at the VREGs. We're going to double check it. We're going to troubleshoot it and find out what the problem is. Okay, but again, if one of these is stuck closed, it's going to allow me to read current all the way through ASICs to ground. Okay, and there's a couple ways you can troubleshoot this. You can simply start removing these VREGs until the short's gone. That's one way to do it, because you're splitting the circuit to 12 volt and then the output side. It's the one place where you can really split the circuit, because it is 3 of them in this parallel. The other thing we can do is use voltage injection to identify either a bad component, because we often will find D1 diode will be shorted. Okay, that causes the same exact symptom that we're seeing. But we can use voltage injection, monitor temperatures and look for a chip that could be causing the problem. So what we're going to do is we're going to get set up here for voltage injection. Got a thermal camera. Get this powered on here. I use a benchtop power supply, and I set my power supply to 4.5 volts at 3.5 amps. All right. No, I don't have a camera feed for this so you guys can see, but what I'm gonna do, turn this on. Same place I was measuring with my meter, I'm going to inject power. So I'm using the negative probe on the outer shroud of the power connector and positive straight to the bottom of the fuse. All right, perfect. All right, so once I did that, go back to the microscope here. All right, so I injected voltage and immediately this VREG lit up. Turn my output off. This VREG warmed up. I could see it in the thermal camera. I could see that we were conducting power through this VREG or the CSD because power converting into heat, right? The voltage injection allows me to use my thermal camera to see that. So worked really good. Now what I'm going to do is I'm going to mark this. And this is a UV marker. You can kind of see it glowing there. That way I don't leave any other tray stuff on the board or the customer might be able to see it. It just becomes an eyesore, but it helps me as I'm going through these and doing inspections, troubleshooting, identifying the problems, and then I notify the customers. So I'll advise the customer, hey, here's what we found, here's the problem. Let me know if you'd like to proceed or not. If you don't, we can mail back, just pay shipping. If you would like us to fix it, then I know I don't have to go back through and take all the steps I just did. So yeah, typically we get these in. This is a very, very common occurrence. And I'll explain in later videos to what we believe the underlying cause of this is. What you can do to help prolong the life of these components. But this particular board is built to the original BOM. I can tell, again, I can tell because these coils are the coils that were called out in the BOM. They're pretty tall, pretty robust coils. All these components are the original BOM size. So this wasn't a modified version of this board. So looks good. This is a Rev 5.1, I think is what this is going to end up being. Yeah, it's a 5.1. And again, it's the Parasite edition, which I think is awesome. They really did a good job on this. But again, these components fail. Overclocking shortens the life. There's a lot of different reasons, but probably one of the biggest ones is heat control. But there's some other things I think that can be done, or some companies have done or haven't done, to help ultimately prolong the life of these components and see better success rates overall. So yeah, I'll reach out to this customer. I'll notify him of what the problem is. For this particular board, it's a $40 repair. We charge $25 for the initial valuation. You send it in. Come here to my bench, look it over, troubleshoot it, find out what the problem is. That's what you get for your $25. Then I provide an estimate back to the customer, tell them what's going on. Again, I'm going to quote this customer $40 for this fix. That includes the time it's going to take to change this out, which we'll cover in another video. The testing of it ultimately. So after I do the VREG replacement, I'll go through, I'll do a test on it, validate it, it's working as expected, send pictures to the customer, say, hey, here you go. This is what it looks like. Here's how it's hashing. Now, what I can't tell, and this is really, really important, is right now I can't run this board. So I don't know if we have a lazy chip. We did do a visual inspection to look for any cracked silicon. That's what you see here. This portion of the chip here is the exposed silicon. So what we'll often see, depending on some of the board manufacturers, especially if they go cheap on the thickness of the PCB, unfortunately a very common occurrence, then we'll get cracks across these. Or if a customer over tightens the heatsink when they're mounting it on, they'll crack these ASICs or they'll break the joints on the side. I can't see any cracks. Everything looks very good. These are BC chips on these 1370s. But I can't tell if they're good or not. I don't know for certain until we get the board up and running. So it could have some lazy chips. It could be a great performer. I don't know, and I won't know because I cannot run this until this gets fixed. So we quote them. Again, this will be a $40 repair plus return shipping. When we get it done, we swap out the chip, we validate, we test it, make sure everything's good to go. And then Customer pays return shipping and it goes back, and they pay the invoice. We don't charge, the customer doesn't pay us anything on the for the $40 plus return shipping until it is complete. We validated it, send it to the customer, the evidence to the customer that it's working fine, and then we invoice, customer pays, and we ship it out. So pretty quick turnaround typically, a couple of days to get these things evaluated depending on workload. You see my bench back here, I start getting them lined up as customers ship them in. So it's, if you want your board repaired, ixtech.xyz, so that's ixtech.xyz. Left-hand side, pull up repair services, fill out the form, pay the $25 fee, and mail it in. It's really important. We're not going to send you return labels or anything like that. You fill out the form. All the instructions are on that screen. You use a carrier of your choice to ship it to us. And then once we get it, I print out the packing slip. It gets in the queue for evaluation, gets evaluated, customer gets quoted. And once the quote's approved, then we get it in the queue for the repairs. So I typically run a queue of both evaluations and a queue for repairs depending on how heavy the workload is or how hard the fix is. So sometimes we come across minor issues. I've seen some of these caps, namely I've seen this cap blown, the D1 diode will get blown. I've seen these VREGs get pretty toasted. Now, I only see really severely damaged VREGs on boards that do not have an onboard fuse like this. So I've never seen one of these Rev 5.1s with a VREG I could not remove. Now, I'm sure we're going to have an example in the very near future of a Rev 6 where they have eliminated the fuse, and they pretty much most of the well, I say most. Solo Satoshi, the primary designer, well, let me back up. Solo Satoshi was the original seller of the Rev 6. Solo Satoshi worked with another US company who designed that, and they released it, probably a joint effort there. They released it to the public. Solo was selling them originally, the first to release it. Great product. They take a little bit different philosophy on the components they believe they need on the board. The fuse was one of those. However, their power supply does ship with a circuit breaker on board, and that's great. But when you change out that circuit breaker or that power supply for something that's not protected, circuit protected, you just run the risk that if you do get a catastrophic short, depending on what power supply you are running, you can have major damage on the board. And we've seen it, unfortunately, all too often. And it's I've seen it on everybody who makes a Rev 6, I say. At this point, I've probably seen 20 or 30 different scenarios of this happening. And so it's unfortunate, but I don't see it with customers who run the stock power supply. I see it with customers who run, well, I should be clear, I don't see it with customers who run the stock Solo Satoshi power supply that has a circuit breaker on it, because the circuit breaker trips quick enough that it protects the board from major damage. So far, that's what I've seen. But I definitely see customers who run mean wells that are pumping them, and that's great, but there's no circuit protection other than the dependency that the mean well is going to trip before major damage happens. And those mean wells are designed to run high loads. So you can imagine it takes a pretty high current before it realizes that there's a problem and causes damage on the board. It doesn't always occur, but it does occur. So common things that we see on these pluses. Again, you know, this is a great example, very clean, original BOM example. Not sure who the manufacturer was for these, but you know, they did a good job. They built it exactly to the BOM and used good quality components. So, all right. Well, I appreciate you guys tuning in. Again, you need repairs for your Nerdaxe, Bitaxe, small home miners, stuff to that effect. Canon to some point, Canon's a very close-sourced ecosystem, so it's really difficult to get parts for them. If you can get them at all, just depends on what the problem is. Yeah, if you definitely need something for your home mining repair, or you need accessories or home miners, please, give us a shot. ixtech.xyz. Catch you in the next one.